Yes, Taha. So I'm starting with the class. So I hope now the internet is better. Uh, you can you hear me?
Yes, ma'am.
Okay. So in the last class, we stopped at this relationship. What was this relation? E is equal to minus dV over dr. Right. Basically, we had seen that electric field is a gradient of potential. Means electric field, it is directly proportional to potential by radius. All right. Now, some details of this were left. When we say electric field as a gradient of potential, there's a concept which is known as partial derivation that we'll do later. First, understand this is change in potential with respect to the position, right? Distance. So this entire term is called the potential gradient. All right. Ex is the electric field along the x-axis. So this is minus dV over dx. Ey is minus dV over dy. And Ez is minus dV over dz. Now E is equal to minus dV over dr. There is a significance of this minus sign. Why is it important? So this significance of this negative sign is basically, see, this negative sign which is put, this basically shows us that the direction of this electric field, it is in the direction wherever the potential decreases. Their electric field has the direction. So direction of this electric field is where the potential decreases. For example, A point has 5 volt, B point has 2 volt. So Ex is delta V over delta X, Ey is delta V over delta Y, Ez is delta V over delta. Do not worry about this. This is actually partial derivation. This is partial derivation. All right. So 5 coulomb, 5 volt and 2 volt. So direction of electric field where potential decreases means 5 volt to 2 volt. This will be the direction of electric. That is towards I cap. Right. So this is how you decide the direction. And to represent this in the formula, we have this negative sign. To show electric field will be wherever potential decreases. Had it been wherever potential increases, we would have used plus, but it is wherever the potential decreases, so we use negative. Write it first, then we'll see some other things. Okay, this is an important question. This is how we can derive electric fields formula using this potentials formula with this relation. See, you know potential is kq by x and it's given in the question too. Electric field is minus dv over dx. So if we put the value of this potential, V is kq by x. So if we put this value here, we'll get d kq over dx, right? What we'll do, we have the constant k over here, right? This is the constant k, constant q, x to the power minus 1, d over dx. This is what we have to do. So k capital Q, x to the power, see, n, you have minus 1 occurs. So minus 1, right? Minus 1, minus 1. So this is E is equal to kq x to the power minus 2. Let's bring x in the denominator. So what will x be? E will be kq by x squared. So this is the relation of formula of electric field. So potential to electric field. This is the only method you can do. Note down this question too. See how to solve this question. This says V is equal to 3x cube. Do not write down anything right now, Taha. I'll give you time to copy, then start copying. Electric field is minus dV over dx. So minus d 3x cube over dx. So minus 3 is a constant. 3 from this cube will come, x to the power 3 minus 1 will be left. So this is minus 9 x to the power 2. Now this says that at x equal to 2 meters. So this was electric field. Electric field, we'll just put the value of x as 2. So this is 2 square. So electric field is minus 36 Newton per coulomb or volt per meter. You can write the same thing with this unit, minus 36 volt per meter. Both are, write down it too. See, the distance between A point and B point mainly are dr is 10 meters, right? And potential is given as 20 volts. So, you know, E is equal to minus dV over dr. And you require electric field. So, electric field is minus 20 by 10. So, electric field is minus 2 volt per. Write it true. Okay, now coming to partial differentiation. How do we differentiate the quantities partially? How this partial derivation is performed? Let us understand this. So see, an equation will be given to you like v is equal to x square y z square like this. The equation will be mentioned. Now, Ex, whenever you have the equation Ex, when you are differentiating it, what's the difference between a partial derivation and a normal derivation? Partial derivation basically means differentiation of this term derivation. This is basically differentiation only. All right. So v is equal to x square y z square. So Ex, when you are differentiating it, Ex for Ex means for the x-axis. This is for the x-axis. Now, in our normal derivation or differentiation, what do? We just write the constant terms first and then multiply it with the exponential power and then subtract the exponential power with 1. This is how we solve. So x square y z square, here nothing is constant term. Every term is variable. So like this, you will be getting questions. So what's the difference between a partial derivation and an actual complete derivation? Difference is that when you are differentiating it for x-axis, your y and z act as constant. See, y and z I have written it also, and this is the way you have to write. Minus del v by del x, and y and z are constants. All right. So if my y and z, these are constants, so y z square will come out as a constant and x square will be differentiated, which will give me 2x. So my answer is 2yz square x and minus, because here is this minus sign. All right, this is one for x-axis. Let's come to the y-axis now. This is specifically for the y-axis. Minus del v by del y. Now, since we are differentiating y, our x and z will act as constant. Understand? Now x and z will act as constant. So x square z square will be written. See, x square z square will be written, and we are left with the variable y. Now see, y has the power 1. So when you write 1 multiplied to 1 minus 1, that gives you y to the power 0. And any constant or variable to the power 0 is 1. So y to the power 0 is also 1. That's why this entire y will just give us 1. So this is minus x square z square. That's it. Now let's come to the z. This is clear. Why this is only minus x square z square? Taha, is it clear to you?
Yes, ma'am.
Okay. So when once you have Ez, this is minus del v by del z. So your x and y are constant. So if x and y behave as constant terms, so x square y will act as a constant and this will come out, right? X square and y will behave as a constant. So x square y will come out. Now we are left with what? We are just left with z square. Now z square is not acting as a constant. It's still a variable for us. So how do we differentiate it? 2z. So we are left with 2z. Right? So minus sign is this. So ultimately, this is minus 2 x square y z. So final answer, final equation of electric field, net electric field will be minus 2x square, not x square, 2x y z square, x y z square I cap, right? Because this is representing our x-axis, plus minus x square z square j cap, plus last term is minus 2 x square y z k cap. Fine. Now the question has one more part. It says calculate electric field at 1 comma 1 comma 1. This means x, y, and z. So electric field will be, this is 1 into 1 into 1 minus 2 I cap. This is minus 1 into 1 minus j cap. This is minus 2 k cap. So this is our electric field. Because it was the vector written, so this much is enough. Had it asked as the magnitude, then we would have calculated the magnitude using the under root form. Write it down to So do not write down anything. First listen to what is potential energy. You should understand potential energy whenever this term comes. Potential energy means some sort of electrostatic interaction has to be present. Now, what is meant by this electrostatic interaction? Basically, forces should be exerted among themselves. All right, forces should be there. So this is a body A. This has, it has a charge, let's say Q1. And there is one more charge, Q2 at point B. And there is third point C has charge Q. Now Q1 can interact with Q2 and Q1 can interact with this Q3. So there is one force possible, second force possible. So as a result, there can be two potential energies possible in this case. This is what is meant by electrostatic interaction. Cause of potential energy is ultimately the electrostatic interaction. Means electric potential energy, if there is infinity, right? A charge is there at infinity. And we are bringing the charge to a particular or respective position. Then the total work done, that gets stored in the form of potential. That's the method to calculate it. But first, before knowing that, you should know na, how much interaction is present or what all forces are acting or how much energy can exert, right? So it's basically about the electrostatic interaction. Interaction means forces. If two charges are available and they can exert force on each other, we will say there will be a potential energy. If we say they cannot exert force on each other, that means no electrostatic interaction. This is what is meant by interaction. So wherever you see two charges which can exert force on themselves, they have a connection. Directly consider and calculate its potential. Write down this introductory part, then I'll start with potential energy of a system of two charges. Okay, Taha. Now see potential energy of a system of two charges when we have to calculate. So see, initially this is infinity and there are two charges Q1 and Q2. Now we have to bring Q1 from infinity to a point A, right? This is Q1 at point A. So when, see, what is potential energy? For potential energy, there has to be some interaction, right? Now, this Q2 is not here. Right now, Q2 is here only. Both the charges are at infinity. I have just brought Q1 from infinity to this A point. Can you tell me there will be potential energy or not? Try, think and answer in the chat column. No, Taha, that is wrong. See, when charge Q has come, there is no other charge to interact. So straight away work done will be zero because no potential energy will be there. See, what did I tell you? There has to be an interaction present for the charges to occur. All right. Electrostatic interaction has to be present for the charges to for the potential energy to occur, right? So Q1 is present, Q2 is there, then potential energy will exist. But when Q1 has come from infinity and there is no other charge present, so there is no charge present to interact with Q1. So how can you say potential energy will exist? No, potential can exist, electric field can exist, but forces, energy, these are not characteristic or properties of a single charge. You can have electric field for a single charge. You can have electric potential for a single charge, but you cannot have potential energy for a single charge. You cannot have electrostatic force for a single charge. Did you understand this, Taha? Okay. So that's why our first work done is zero. Now I have brought Q2. So there is an interaction. Now there can be force, there can be energy present and all the quantities to exist. And the separation between them, this is R1, 2. All right. So work done in carrying Q2, see VB minus infinity. Now remember at infinity, what will be the potential? No electrostatic field is present. So no potential is straight away present. So at infinity, potential will be zero. VB is equal to K Q2 by R12. Okay. So work done from infinity when you are when you're checking. So this Q2 gets multiplied to K Q2 by R12. See, what's the potential of that charge Q2? K Q2 by R12. So when this gets multiplied to this Q2, it becomes K Q1 Q2 by R12. And when you add the total work done, what do you get? You get the total energy gets stored in the form of potential energy K Q1 Q2 by R. This is the potential energy of system of two charges. Write it down, then we'll see if there are n number of charges present. First, let us see for two charges, right? let's see for n number of charges. Now what will happen, Taha? See, when we brought the first charge, that is 0. Second charge got us k q1 q2 by r1. Now if we get a third charge, so third charge will interact with the first charge and it will interact with the second charge, right? So when you are using work done in carrying charge Q3 from infinity to a point C, right? So work done from infinity to point C. This is, so this is from infinity, VC minus V infinity. So again, same thing. You know this VC, this is KQ1 by R13. This is for the next charge Q2, interaction due to second. So for 3, you get both of these, right? So 1 and 3. Then 2 and 3 for 3. Now when Q4, suppose Q4 also comes. So one more will be added, Q3 into Q4, right? If nth charge, so n number of charges will be added. And ultimately, you will add all the work done and you'll get the total potential energy. So what will be the total potential energy? You just take 2 charges and divide it by the radius. Take two charges divided by the radius. Take two charges divided by the radius. Take 2 charges divided by the radius and ultimately add them. This is the manner for n number of charges. Quickly write down this 2.